going to talk about what sets are and different ways to represent sets. So first, what exactly is a set? A set is just a collection of objects which are known as elements. In addition, sets are always enclosed in braces. As an example, if we wanted to list the primary colors, we would have an open brace, red, blue, and yellow, and then we would close our brace. So here's an example of a set. We will introduce one special set first, which is called the empty set. The empty set is just the set with no elements. And there may be a few reasons that we want to use this set that contains no elements, and there are two ways to denote it. A circle with a line through it denotes the empty set, as well as an empty set of braces. However, one of the biggest mistakes of denoting this for beginners is combining these two, and this is actually not the same thing as the empty set. If you're curious, you can go into a little bit more set theory, but for now, let's just know that this is not the same thing. We're going to look at two different ways to represent sets. The first is known as the roster method. Here, we just list the set elements between braces. Earlier, when I did my example of my primary colors, that used roster notation. A couple more examples. We could have this set containing 0, 2, 4, 6, and 8. Maybe we want to continue this pattern indefinitely. And if we want to continue a pattern indefinitely, we use an ellipses, a dot, 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 to indicate that you keep going. And there may be a reason that you want two ellipses, one on either side. So maybe we want to consider the negatives as well. So we would have an ellipses at both the first and the end of the set. Our second method is known as set builder notation. This is the general form of set builder notation. The braces say the set of. This then says all x. The vertical bar reads such that. And then we have some description to describe what's going on in our set. I'm going to rewrite my examples from the roster method in set builder notation. My first one, I had the set of all x such that x is even. And my first example started at 0, but not past 10. So the set of all x such that x is even and 0 is less than or equal to x is less than 10. There may be other ways we can do this. We could say less than or equal to 8. We could say less than 9. But this is just one example. My next example was where I kept going infinitely. So we say x is even and x was positive, or really non-negative since it included 0. So we need x to be greater than or equal to 0. My final example didn't include negatives, so we just had that x is even. So the set of all x such that x is even. In mathematics, we do have a few special sets that have special names that we use quite often. The natural numbers, which we denote by this special N. This is a font known as Blackboard Bold. These are our counting numbers 1, 2, 3, 4, 5, 6, etc. The next one are the whole numbers. We now include 0 as well, so 0, 1, 2, 3, 4, 5, etc. The integers now introduces the negative of the whole numbers, so it's the whole numbers plus their negatives. The rationals, these are all numbers that can be written in fraction form, so x is equal to a over b, where a and b are integers, b not equal to 0. So it's anything that can be written in terms of a fraction. When we look at decimals, these are any decimals that are either terminating or repeating indefinitely. The irrationals are then the opposite of the rationals. These are things that cannot be written as a fraction. Anything with a non-repeating, non-terminating decimal. The last one we'll look at here are the real numbers. This is what happens when we combine all of the rational numbers with all of the irrational numbers. We get the real numbers. The next thing we want to look at for a set is what's known as a subset. We call a set A a subset of B if all elements in A are also in B. Our notation looks like this. That says A is a subset of B. The idea is the first set is actually contained inside of the second set. A couple of examples. Our natural numbers, which were 1, 2, 3, 4, 5, etc., is a subset of the integers because all of the natural numbers are also inside of the integers. However, it doesn't go the other way. Z is not a subset of n because, for instance, -1 is in the integers, but it's not a natural number. Another example, if I consider the sets I had earlier, I have that my first set that goes 0 through 8 of the even numbers is a subset of the non-negative even numbers. There are two ways that we'll look at to combine sets as well. The first is called the union. The union of two sets A and B is the set of all elements that are in A or in B or in both. And it's denoted by this U-looking thing for union. This is read A union B. And we essentially take the two sets and combine them into one big set. My next operation is called the intersection. The intersection of two sets A and B is the set of all elements in both A and B. This is denoted by this symbol that essentially looks like an upside down union symbol. The idea is we want to know what the two sets have in common. So let's do some examples. For our first example, we have 0, 2, 4, 6, 8 unioned with 0, 3, 6, 9. The union essentially means combine these two sets into one. So I have a 0, a 2, a 3, a 4, a 6, an 8, and a 9. And every element in either one of these sets is now in my new set. If I do the opposite and try to do an intersection of these two sets, I only care about the numbers that are in both. We can see that 0 is in both of these as well as 6, and those are the only elements in both sets. We'll do one more example. If I have the odd numbers 1, 3, 5, 7, 9, and I want to union with my even numbers 0, 2, 4, 6, 8, my union would then just be all of the numbers between 0 and 9. On the other hand, if I try to intersection these two sets, so I have my set 1, 3, 5, 7, 9 intersected with 0, 2, 4, 6, 8, we want to know the numbers that they share. And we can look and see that there's no elements that are in both of these sets. There's no number that's in both of them. And this is the reason we have the empty set.